In real engineering assemblies, components like bolts, washers, nuts, and bearings are used everywhere. Modeling these standard parts manually is not only inefficient but also unnecessary. This is exactly where Toolbox in SolidWorks becomes extremely powerful. In this session, we'll work on a realistic mechanical assembly and transform it from this to this entirely using Toolbox components without needing to model a single part manually, learning how to quickly insert and manage fasteners, bearings, and other standard hardwares directly from the Toolbox library. We also learn how to customize and save our favorite components in a dedicated folder for quick access, so instead of searching through standards and folders every time, your most used parts are always ready to use. Let's get started. So this model is a combination of the pillow block and the gearbox, and we need standard parts like gears, bearings, retaining rings for holding the bearings on their places, and keys to hold the gears with the shaft, and of course some fasteners. Not only we learn how to import them, but also how to adjust their parameters. But first thing first, we need to activate the toolbox. One of them is to go to SolidWorks add-ins and activate it from here, or from the settings go to add-ins, or activate it from here. The third method is to go to the toolbox and activate it from the right panel. So every key I press on my keyboard, I show it down here so you can learn and get used to them. So let's start with the pillow blocks fasteners. From the right panel, go to design library. First we need to select the standard, DIN, and we have different type of standard parts here. Let's go to bolts and screws, hexagonal socket head screws, and I'm gonna drag hex socket head D912 directly into the hole. SolidWorks figures out the parameters automatically and I only need to release it. And on the left side, I can see the parameters, and for the length of the fastener, I can pull this arrow back and forth, so I need to change the display side to wireframe and adjust the length just like this. Bring it back. The moment I confirm it, I can add the same fastener for the same holes. So what I need to do is to apply another fastener for this hole. And then I'm gonna cancel it. The next item is a bearing inside this housing, and I have a retaining ring next to it. Let me take a section. This is the groove for the retaining ring, and I extracted its parameters from the standard tables. So go to the design library, go back twice, and go to the bearings, select ball bearing, and drag a radial contact ball bearing directly into the housing or the shaft and release it. Again, SolidWorks figures out the parameters, but if it was anything different, you can change them from here. The bore is 15, the OD is 32, and the thickness is 9 mm. Confirm it. I don't need anything more of this bearing type, so I'm gonna cancel. Now I need to add some mates. For example, the bearing sits on this area. Select this one, and while holding control, select this and select coincident. Next, I have a retaining ring as I told you, so let's go to the design library and go back. Retaining ring, internal. So I'm gonna drag it directly into the groove, and the parameters is exactly what we are looking for, and I'm gonna confirm it. We have 6 other bearings with their retaining rings here as well. So what I can do is to hold control and drag the bearing so I can create the copy from it. I need to add another one. Confirm it. Now I have a mate between these two faces of distance, and it is 9 mm. Confirm. Also this one. I have 2 other bearings for these 2 shafts as well. So let's go, and I'm gonna go to the ball bearings and drag another bearing into this housing. The size is 6004, which is okay. And cancel. Let's add another one for this shaft. And this one is 6005. Confirm it. For these 2 ones, I can use mirror. So let's go to the assembly, and from the linear component pattern, select mirror components. And in the mirror, I need to go to the right panel of the lower shell And in the components, I'm gonna select these two components and confirm it. Of course, they have retaining rings as well. I leave it to you. You can add them yourself. Now let's hide the upper shell completely to see what's going on. We have 4 gears with their keys. Now let's go to the design library and I'm gonna go back twice again. Let's go to the power transmission, gears, and I'm gonna drag a helical gear directly into the shaft. This time we need to define the parameters ourselves. And for example, the module is 1, the number of teeth is 31. It is left hand and helix angle is 10. Face width is 30, the hub style is type A, the nominal shaft diameter is 50 mm, and the keyway make sure is set to square 1 and confirm it. I'm gonna cancel. Also, I have a mate between this face and this one. Of distance, it is 48 mm, confirm it. Next, I have a key for this slot and the slot on the shaft. Now again, I'm gonna go to the design library and open the key, select parallel key, and drag it into the slot. The shaft diameter is between 12 and 17 mm and the length is 36, confirm. I don't want to add anything more of this type, cancel it. Now I have a mate between this face and this one, coincident, and also I have another mate type between this and this one, which is concentric. I need to add another gear as well, so let's go to the design library and go to the gears and drag a helical gear for the middle shaft. Now the module of the meshed gears are the same, so the previous one was 1 and this one is also 1. The number of teeth is 82. This one needs to be right hand. Helix angle is 10, the pressure angle is 20. And the shaft diameter this time is 20 mm, and also this one is a square 1 as well, confirm it. Also I need a key for this, so I'm gonna go to the keys. Let me find the slot and I'm gonna drag the key directly into the slot. Now this time the shaft diameter is between 17 and 22 mm and the length is okay, so I'm gonna confirm it. Now these two faces are coincident, so I'm gonna apply it, and also these two faces are coincident, and we have a concentric mate between these two faces. Apply it here as well. This is our gears. Now I want these gears to rotate correctly together, which means if I rotate this one, the other one rotates with it accordingly. Now for this I have a very special mate, but first let's adjust their position together, and from the mates go to mechanical and select gear mate. I need to select the tip faces and the ratio is their teeth ratio. For example, the bigger one had 82 teeth and the other one had 31. Confirm it. So if I rotate the first one, the other one rotates with it accordingly, with the proper rotational speed. So that was everything about how to import the gears and their keys into the model. I have imported the next two ones with their keys. Now that everything inside is set, it's time to assemble the upper shell using fasteners. So let me bring the upper shell. And if there is a lot of holes and a lot of fasteners, it is not very recommended to add them manually. Instead, we have some very useful tools like a Smart Fasteners and pattern-driven component pattern. Let's start with the Smart Fasteners. In the selection, select a hole, hit add. Now, based on the hole size, it figures the fastener type properly, but if it was wrong, you can change by right-clicking on it and change the fastener type. Also, it adjusts the length of the fastener by the thickness of the feature automatically. See this arrow? Pull this back and forth to change the length. Top stack is the top of the fastener, so you can add accessories like washers. The size, you can change it here, and the thread display, everything is set, confirm it. And also Smart Fasteners is added to the design tree with all the stuff that we have imported from the library. This method is way faster than add them manually one by one. The next tool, as I told you, is pattern-driven component pattern, and for this I need to bring the fastener once. I'm gonna drag it directly into this hole, and let's make sure about the length and confirm it. Now if I go and select the pattern, the first item is to select the component and the second one is to select the feature, and it populates all similar features with the same fastener, then confirm it. If you want my opinion, first use a Smart Fastener since it gives you more flexibility about the fastener type and its belongings. If it wasn't possible to use a Smart Fasteners, use pattern-driven component pattern. But another thing you need to know is that we usually have one set of components for our models and one standard. So it is kind of frustrating that every time I need to go to the right standard, then to the right type, then go to the right model and find my favorite part. But wouldn't it be awesome if I had a folder including all my favorite parts to stop me from jumping between different standards and different folders? Of course it would. Luckily in SolidWorks we can have that folder. So let's go and right click on the empty space of the toolbox and hit configure. Let's go to home. The first tab is about Hole Wizard, the second one is about customize your hardware, the third one is to define user settings, set permissions, etc. We have something to do with customizing your hardware, so let's go to it. And first thing you need to do here is to deactivate the standards you don't use. For example, I don't use IS, I don't use GB, I don't use CISC. So I'm gonna deactivate all of them. And the second one is that I can have that customized folder here. So right click on the toolbox standard and create a new folder. Rename it to my parts, confirm it. So in this folder I can have all my favorite parts. Let's go to DIN and bearing, ball bearing. Right click on radial contact ball bearing and copy it. And then right click on my parts and paste it here. It is added to my folders. Of course I want to add some things like hexagonal socket head screws, and right click on it, copy, paste it here. And for example I can add some nuts. Let's go find some nuts here. And I'm gonna import the hex nut by copying and paste it here. You can add some other things here as well. For example, if you wanna, you can add helical gears too. Once you're set, hit save. Now in the toolbox we have the folder that we just created, my parts, and inside it I have all my favorite parts. And with that, our assembly is fully completed using Toolbox in SolidWorks. As you've seen, using a standard components from SolidWorks can save a huge amount of time and make our modeling workflow much more efficient and professional. We'll continue exploring more powerful tools and engineering workflows in upcoming videos, so make sure to subscribe to the channel. And as always, from one engineer to another, see you in the next one.